Swayam Prabha. Digital India. Educated India.
Hello everyone. So, our next fiber we will discuss is flax fiber, which is natural fiber. In a discontinuous form, we get it from the skin of the stem. It is a bast fiber. So, natural cellulose fiber obtained from the stem of flax plant. It can be as long as 150 centimeter, very long 1.5 meter fiber. So, typically from 25 centimeter to 150 centimeter, relatively coarser fiber, not very coarse, basically it is a 12 to 16 micron, slightly convoluted smooth surface with nodes along the fiber length. And with longitudinal serrations are there, sometimes we get. Now, if we see the chemical characteristics, these are basically cellulose fiber. So, it is a resistant to dilute alkaline, mercerize improves its luster and strength. It is damaged by strong mineral acid, resistant to dilute organic acid, bleached with hydrogen peroxide or sodium hypochlorite, we can bleach it, resistant to most of the organic solvents, acetone, alkaline, alcohol, and burns readily with a paper like smell like cotton. If we see the thermal characteristics, flux has no melting point and decomposes before melting due to cellulosic nature. So, like cotton fiber, it begins degradation around 42 to 50 degrees Celsius. So, just like cotton, it rapidly breaks down above 300 degrees Celsius. Ignition point is 480 to 500 degrees Celsius, and it rapidly burns and gives us paper like smell. Prolonged heating causes yellowing and loss in strength. Thermal conductivity is higher than cotton and wool fiber. So, it is that is why this fiber is typically called as a cool fiber due to high Qmax, that is a instantaneous heat absorption, losses insulation ability when wet, but still dries quickly, because insulation its thermal conductivity increases with the moisture absorption. Flammable like other cellulose fibers, okay, but with less afterglow than cotton. Cotton gives the higher afterglow. Mechanical characteristics of flax fiber: tensile strength is very high, around 5 to 6.5 gram per denier. It is a stronger, much stronger than cotton. Elongation at break is typically 2 to 3%, lower than cotton. It makes flax stiffer and less elastic. Elastic recovery is poor, limited flexibility compared to wool and cotton. So, it gives lower elongation, but the uniqueness is there. It is basically it is stronger fiber, and also it is its thermal conductivity is more. So, gives its cool touch, and due to the higher Qmax value, Qmax means instantaneous heat absorption, this fabric made from the flax fiber is for summer wear, and due to the high tensile strength, very high tensile strength, this is used for technical applications, different protective application we can use. Abrasion resistance moderate and does not spring back easily because of its lower elastic recovery. Okay. The applications we can see here, textile and apparel application, we can use handkerchief, napkins, towels, home furnishing, curtains, draperies and cushion cover. So, fire hose, tents, industrial bags, due to its higher strength, automotive and cushion, in the construction industries we can use, medical linen bandage, we can use medical applications, we can use the canvas. The multi-filament fibers are basically continuous filament. These are maybe natural and also in synthetic form. So, the structure of multi-filament fibers are where a number of continuous filaments are bundled together. So, that is a multi-filament fibers are there, smooth and uniform structure because of the continuous length, high tensile strength, because the staple fibers are discontinuous, they are actually tensile strength comes from mainly the frictional cohesion and fiber to some fiber strength like cos component, as I have mentioned, cos theta component of the fiber strength. So, here we get the in multi-filament yarn or monofilament yarn, the actual fiber filament strength is used 100%, flexible and soft, producing lustrous fabrics, but this yarns are not as soft as the fabrics are not as soft as the staple fiber fabric. It can be textured or twisted for bulk and elasticity. So, if we want to increase the elasticity, so we can if we apply twist, the elasticity will increase, and bulk if we want to increase, so we can form a texture. So, like this is the, suppose it is a multi-filament yarn, here the bulk is not that high. So, if we want to create the bulk here, so if we just simply incorporate loop in the individual filament, so then it will create the bulk, it will entrap the air within that this yarn structure. Acrylic, silk fiber. So, there are many multi-filament fibers are there. We are not going to discuss all the fibers. So, only 2-3 fibers we will be discussing. So, chemical characteristics depending on the chemical nature of the polymer. So, chemical structure, because depending on the fiber it is a synthetic or nature. So, what is their composition. So, that actually whether it is a chemically stable, that depends on the fiber type, and dye absorption also depends on the type of fiber used, and it is whether it is resistant to chemical, acid or alkali, that depends on the type of fiber. And the it is less prone to degradation than fiber, staple fiber. That is basically due to the structure of yarn. For same fiber, for same fiber, like acrylic, if we use the acrylic in the filament form and acrylic in staple form, typically the degradation on the staple fiber material will be little bit higher because of the structure, and it can absorb more chemical and gets degraded. Thermal characteristics of multi-filament fibers, again it depends on the type of fiber. It varies, synthetic or natural fiber, and synthetic multifilament may melt or shrink at high temperature, but natural multifilament, that is a natural filament yarn, is basically silk is an example. So, natural multifilament can char or decompose under heat. So, silk is one natural multifilament, that is the only natural multifilament we can say. Continuous structure can provide moderate thermal insulation. So, if it is staple fiber, then we can have air entrapment, and that the thermal insulation may be higher. So, mechanical characteristics, it will be higher tensile strength due to continuous structure, good elasticity and flexibility, smooth surface, basically due to the structure, continuous structure, the surface will be smoother than the staple yarn, and durable and resistant to breaking strength. Applications like shirts, dress materials, sportswear, home textile, we can use curtains, upholstery, industrial rope, nets, tire cords, there we need the multi-filament yarn. Tire cord we cannot use the staple fiber. Technical textiles we can use filtration, composite, and geotextiles we can use this multi-filament yarn. The silk is the one example of natural multi-filament yarn. Now, let us see the structure of silk. This is the structure, typical structure here. Okay. This is the micro fibrils are there. It has got two components, one is a sericin, which is a gummy component, and fibroin. So, it is a natural protein fiber from silkworm composed of mainly fibroin, which is the core, which actually the fibrous component, and sericin, which is coated by the this sericin gum, and in ultimately when we use the silk as a fiber, we have to remove the sericin component. So, fibroin rich in glycine, and alanine and sericin, okay, serine. So, these are the different components from tightly packed chain So, this forms the tight, this is a tight, you can see these are very tightly packed chain with strong hydrogen bonding. So, this actually gives a high strength, it provides 65 to 70% crystalline, beta sheets gives strength, while amorphous region adds to flexibility. So, that is a silk fiber structure. It is basically typically triangular or irregular cross section with round corner. So, if you see the silk fiber, so at the corner this is a little bit round corner, okay, which actually refracts light, creating sheen and lustre. So, that is the beauty of the silk fiber, which makes the this is a natural fiber which is becoming lustrous. So, due to the triangular cross section, but at the corner this is a round corner. So, this shape refracts the light, smooth soft surfaces covered by thin layer of sericin and removed during the degumming. So, we can see here this is the silk fiber, typically triangular shape with the round corner, and this is covered by the sericin, thin layer of sericin, and degumming is required where we remove the sericin. It is very fine and uniform filaments, 10 to 15 micron in diameter. Molecules are highly oriented along the fiber axis, which enhance the strength, tensile strength. Now, if you see the chemical characteristics here of silk fiber, it is a rich glycine, alanine and serine. So, glycine, alanine and serine, okay, which enables tight molecular packing. So, these are the that is a tight molecular packing, insoluble in water, but soluble in strong alkyl acid. So, as it is in strong acid, it is soluble, concentrated alkali and certain salts. These are actually, this can be dissolved, resistant to weak acid, but damaged by strong acid, because it is becoming soluble in the strong acid. So, weak acid we can this is resistant, weakened by prolonged exposure of sunlight, good dye affinity due to amino group in fibroin. So, due to this amino group, the dye affinity is very good. It can be, it is damaged by the easily with the chlorine bleach. Now, thermal characteristics, you can see silk has no melting point and it decomposes on heat due to its protein nature. It loses strength at 140 degree Celsius, decomposes 170 degree Celsius. So, we can use the wool silk fiber at low temperature application, burn slowly, leaves crumbled ash with a smell like burning hair, like other animal fibers also. low thermal conductivity, it is good for insulation and comfortable wear. So, that due to the low thermal conductivity in earlier days the old earlier days so we use silk was used for the cold climate clothing also, mainly wool, silk there people used to use. Moist heat, steam or boiling weakens the fibre. Now, mechanical strength of silk is very good. So, high tensile strength and fibrovin beta sheet gives durability. So, that is why in old days this silk fibre was initially used as a protective textiles from mechanical threads. Moderate elasticity, stretchability is 15 to 20% is breaking elongation, crease resistance is poor, it gets wrinkle easily, very fine filament contributes softness and sheen, abrasion resistance is moderate, under repeated rubbing the fibers gets weakened, it gets damaged. The applications, textile and apparel, even sari, dress, shirts, we use this silk fibre, home furnishing, curtains, upholstery, bed linen, industrial applications. So, in parachute, surgical switcher, protective clothing we can use, as I have mentioned that a mechanical thread. So, we used to use the silk fibre, blended fabric combined with wool, cotton, synthetic fibre to enhance its texture and strength. So, silk can be blended with other fibers. So, there are different products are there, specialty products, silk carpets, embroidery threads, art canvas. This is acrylic is continuous filament form, or even in the staple form we can use the synthetic fibre, and you can see the acrylic structure. Synthetic fibre made from the polyacrylonitrile, linear polymer with a repeat this is the repeat unit CH2 CHCN, semi-crystalline or crystalline region are provided provide the strength, amorphous region provide the flexibility, usually round dog bone or triloval structure that we get, and smooth surface. And chemical characteristics, if you see here, it contains C triple N bond end CN group, along with the polymer backbone, responsible for chemical stability and dye affinity. So, triple bond is actually his nitrile bond, which is responsible for chemical stability. Insoluble in water and most organic solvent. This is chemical protection we can use, resistant to acid, alkaline and microorganism. It does not get affected with the acid, alkali or microorganism. Swells in strong polar solvent like DMF, can be dyed with basic cationic dye, and sometime modified for alkali or dispersed dye. So, silk is basically the alkali acrylic is used mainly where the attack from acid, alkali or microorganism is there. So, that all this protective application we can use most chemicals, but may decompose. It is resistant to most chemicals. The thermal characteristics, no true melting point, decomposes on heating around 200 to 300 degrees Celsius, maintains a shape of up to 150 degrees Celsius. Prolonged exposure at higher temperature causes degradation. So, for low temperature application, silk acrylic is very good, burn slowly with smell. So, for fire protective application we can use the acrylic fiber, that is mod acrylic is used for all this application. Low thermal conductivity, fiber provides good warmth and insulation, that is why for woolens it replaces woolens, and cold weather clothing we use the acrylic fiber also. Hot steam and ironing at high temperature may cause shrinkage. So, that is why we have to because of the low exposure that maintains shape at low temperature and moderate temperature, we can use this acrylic fiber. So, mechanical characteristics you can see its tensile strength is moderate, generally weakens, that is it's weaker than wool and nylon. Moderate elasticity, 10 to 20% breaking elongation, it is a good recovery from bending, making it wrinkle resistant, and it is basically bending strength is very high. So, that is why this fiber in woolens we use this fiber, and it gets peeling. Acrylic presence of acrylic fiber creates a peel in the woolens. Soft and wool like, suitable for warm and comfortable fabric. Abrasion resistance is moderate and may peel with prolonged rubbing. So, this is due to the high bending strength. Low moisture absorption, 1 to 2%. So, minimal weakening when wet. Resistant to insect. So, most of the chemical it is resistant. So, we can use in many protective application. So, applications you can see here obviously clothing and apparel widely used for sweaters, socks, scarves, gloves, home textile, blanket, carpets, upholstery, curtains. Industrial uses outdoor fabric, awnings, insulation materials we use because it is not affected by the environmental condition easily, and blended fabric blended with the wool and cotton improves the texture. Specialty products, yarn, craft wool and knitwear. Now, coming to one specialty fiber which is nowadays in modern era, the applications of coat sheath fiber is very widely people used to use this fiber. Now, if we see the structural characteristics, composed of two distinct components, a central core and outer sheath. So, if you see the coat sheath fiber can be it can be spun in the through the by modifying the spinneret. So, in coat sheath fiber, one example is the low melt fiber. Suppose polyester, or we are trying to make nonwoven. In nonwoven industry, particularly for applications like filter fabric, we use the bicomponent here. In the course of it is a, we can call it as bicomponent fiber, coarse sheet type fiber, where the normal polymer is at the core and it is low melt polymer we can use at the sheath. So, and after making the nonwoven fabric, and that if we use the thermal bonding, hot air bonding. So, this low melt fiber will melt and form the bonding. Okay. So, this very wide applications are there. Now, core provides strength, elasticity and or other mechanical characteristics. So, this core fiber will provide the elasticity and strength. The sheath enhance the surface properties like softness, dyeability, chemical resistance. So, this is as I have mentioned, is one of the applications, but if we want to have high strength and dyeable fiber. So, we can use some polymer at the core which provides high strength, and at the same sheath that we can use the dyeable fiber. Can combine natural and synthetic material or two synthetic material for tailored performance. Often produced as continuous filament. Hollow polyester fiber is also one example. Now, chemical characteristics, we depends on the type of polymer we use. Core and sheath can have different chemical resistance, different due to the different presence of different polymer. Sheath are often designed for dyeability, chemical protection or UV resistance. So, we can use such polymer at the sheath, which is shown as the polymer sheath at the blue color. There we can use polymer like which will be UV resistant or dyeable, and core we can use a polymer which will provide high strength. Core may provide chemical stability, strength or elasticity. So, it allows construction of fiber behavior under acid, alkali solvent. So, we can customize the fiber. Thermal characteristics again depends on the type of polymer. So, the thermal characteristics of core can provide the heat resistant or thermal stability, and the sheath fiber often low melt fiber, as I have mentioned, low melt polymer we can use for bonding or surface modification. So, for, after making the nonwoven we can use we can melt it, melt the low melt component at the sheath, but the core component it is actually it is thermally stable and it provides a strength. Designed to withstand specific temperature range depending on the application. Continuous structure help maintain insulation. Now, mechanical characteristics of core sheath fiber. The core provides high tensile strength, elasticity and durability. The sheath improves the surface softness, abrasion resistance and flexibility. The synergic structure enhance overall mechanical performance. So, core and sheath if you take together, so it will improve the overall mechanical performance. It can be engineered to stretch, resilience and dimensional stability. So, what are the applications? Let us see the applications. Stretchable fabrics like elastic, sportswear, hosiery. So, where in the sheath, in the core we can use the polymer with high stretchability. Technical textiles, medical suture, industrial cords, filter fabric. So, filter fabric to retain its structural integrity. So, we use the low melt polyester bicomponent fiber with the low melt polyester polymer at the surface at the sheath. Composite materials for enhanced strength and surface properties. In a protective textiles widely used nowadays in core sheath type of fiber. Next is the microfiber. Microfiber actually is nowadays widely used for many protective applications, particularly for protection from bacteria, virus, like in filter fabric it is used widely. Mask. Now, structural characteristics of any microfiber, it is basically very fine, it is extremely fine, usually less than 1 denier in diameter, 1 denier fiber. So, it is very fine in diameter, can be continuous filament or cut into staple. High surface area relative to weight. So, because of the very fine fiber, so specific surface area will be very high. It is as the fibers are fineness is or fiber diameter is very small. So, it is its bending rigidity will be very low. So, it becomes soft, flexible and lightweight. It can be woven into fabric or non-woven to produce dense smooth fabrics. So, polyester, microfiber, nylon, polypropylene, different types of microfibers one can get. Chemical characteristics depending on the type of polymer mainly, it is depend and it whether it will be chemically stable or not, that depends on the type of polymer, and acid, alkali, solvent activity, it again depends on the type of polymer, and it can be engineered to enhance the durability or strain resistance, low reactivity, okay, depending on the polymer, makes them durable in a harsh environment. So, this actually microfibers are mainly made from the polyester, nylon. So, that is why they are durable in a harsh environment. Now, thermal characteristics again depends on the type of polymers being used. Heat resistance depend on the fiber type like polyester, nylon, etc., and synthetic microfiber may melt or shrink again depending on the type of polymer. It can provide good insulation due to the fine fiber and high surface area, that is a good insulation it can provide. Continuous structure helps maintain fabric shape under moderate heat. Mechanical characteristics, you can see the high tensile strength relative to diameter, it is soft, flexible and resilient, durable with good abrasion resistance. this fine structure it is used for apparel, sportswear and different outerwear we can use, even inner garment we can use because of the very soft feel. Home textile, cleaning cloth, upholstery, bedding. So, all this application, industrial filter, wipes, insulation material, we can use microfiber, medical fabric, protective text clothing, composites. So, you will see the microfibers are widely nowadays used for protective textiles. We will discuss in detail the areas. Next come the new generation fiber, which is nano fiber with a very fine in diameter, in the level of nanoscale. The structural characteristics of nanofiber, you can see the nanofibers are there. Extremely fine fibers, typically less than 100 nanometers in diameter, very high surface to volume ratio. That is the actually uniqueness of this nanofiber, which changes the characteristics for the same polymer. If we create the nanofiber, so the fiber characteristics in the nanofiber or normal fiber will be entirely different, can be continuous or in nonwoven matte, lightweight, flexible and often porous. For example, silk nanofiber, cellulose nanofiber, polyurethane nanofiber. So, these are the different types of nanofiber. As I was mentioning, the silk nanofiber, the characteristics of silk nanofiber will be entirely different from the normal cellulosic fiber due to the very high surface area. Chemical characteristics again depend on the type of polymer is being used, like carbon nanotube, it is where it is made of carbon, chemically stable depending on the material, synthetic or natural. It is actually depending on the type of polymer, it can resist acid, alkali or solvents. Surface chemistry can be modified for hydrophobicity, hydrophilicity or functionalization. So, high surface area allows enhanced reactivity and coating capability. This is important for nanofiber. So, you can see the high surface area which actually enhance the reactivity. So, its total characteristics changes, keeping the same polymer. If we enhance the surface area, it will change the reactivity and coating capability. Now, thermal characteristics of nanofibers: heat resistance depend on the fiber material, synthetic or natural. Synthetic nanofiber may melt or degrade at high temperature. It can provide thermal insulation due to the fine diameter and porosity. It is often used in applications requiring lightweight, heat resistant mat. So, these are the specialized applications. We have to find the applications of nanofiber. So, mechanical characteristics: high tensile strength relative to diameter. So, that is the uniqueness where we need very fine material with high tensile strength. So, nano fiber is used, and nano fiber is actually used in composite nano powder or nano cellulose is being used for composite making. It is due to its very fine diameter, it is lightweight and flexible. It can be engineered for toughness and elasticity. So, that we can create the fiber often forms strong non-woven mats with good structural integrity. So, nanofiber can be directly non-woven can be created, and which will be good with a good structural integrity due to very high surface area. And the applications of nanofibers, you can see the wide area in filtration. So, in protection from the environment like water pollution. So, that for that those applications nanofiber is widely used. In medical textile wound dressing, tissue scaffold, drug delivery, their nanofibers are used widely. In protective textiles like protection from chemical, biological or fire resistant fabric. So, these nanofibers are used. Electronics and sensors, conductive mats, battery, where we use these nanofibers, and composite reinforcement in lightweight material. So, very lightweight composite reinforcement we can use this nanofibers. Now, we will start the yarn structure, different types of yarns which is used for different protective textiles. So, this will continue in the next session. Till then, thank you.